this it's as I know, it's like all of you are from various backgrounds, so I will try to keep the talk as much as possible, not too technical, but at the same time, those who are from the domain of an AI and machine learning, they will not feel that they had not learned something else. So that's why I will try to keep both the stuff in a way possible to understand to everyone in the audience. Okay, so so I currently am in the Department of Brain and Cognitive Sciences at Massachusetts Institute of Technology, but I will be talking about more of the work which I carried out in the during my doctoral thesis. Okay, so let's get started, and it's like the topic is like bridging the gap between human and machine intelligence. So so in today's presentation, I will be more covering these topics in a broader sense, as in we'll start off with understanding what is intelligence, recent developments in AI, and I will just take a case study, which is my doctoral thesis, some of the bits from that thesis, that how you can use experimentation with humans to make the AI models more better. And we'll look for the other projects which I'm currently in at MIT. Let's start with the motivation. So when I say whether this AI models are really not doing well, that's the main question that has to be addressed, and how humans are better as compared to the artificially intelligent model. Let's assume that I am showing you a picture here. That is the top right, top left picture. So here you can see clearly. You can see here it is a picture of a monkey with a tree or something, right? But when you keep a bicycle in this picture, and if you give this image to the AI model, then the monkey is classified as a or recognized as a person, right? Similar goes to the like the next picture also. When you give this image as an input to an AI model, it also recognizes it as monkey and person, right? So just a second. Yeah. So this is a picture from one of the paper from 2017, that is visual concepts and compositional weighting. So all the references are mentioned at the bottom of the each slide. And if we go from the recognition model and from the natural or NLP problem, we can see that 1999, 1888, 1777 has been correctly classified or correctly recognized or interpreted by the AI model. But when we give this 1111, then AI model may give you an outcome that 11T1T1. So there is something which is missing in the AI models, and that's why we need to understand how this AI model works and what are the underlying principles for this, right? So in order to understand that, we need to understand what exactly the intelligence is. Intelligence is the ability of a person or thing to apply the methodological knowledge and then take a decision in favor of a particular class or in favor of any decision, right? And if you broadly classify intelligence as like two, as in natural or human intelligence and artificial intelligence. Okay. Now we will just focus on one problem, which is recognition. So let's assume what do we mean by recognition is the identification of a person or an object from your previous knowledge. Let's assume I'm showing you a picture here, and you may say that this is a picture of some kind of a bird. So what you exactly do is you just try to look or try to identify different features of that bird or different features of the image that is being shown. As you mentioned that it's as you recognize as it's a bird category, you say that how is the body of that bird, how is the neck, how is the beak of that bird, and based on it you take a decision. Yeah, this is something of category bird. Okay. Now when you see these characteristics of a particular category, then these constitute to a features, and now these features are given to the classifier, and the classifier gives you an outcome, what kind of a picture that is. Okay. When you combine these features and the classifier, then you come up with a model, which is nothing but either it will be a machine learning model or a deep learning model. Okay. So in a nutshell, you can just say that the feature extraction and the subsequent classification of the features constitute a ML or DL model. As simple as that, right? Now, if we get some more complicated image, what happens here? Now, the image is very complicated and one has to look very carefully and identify the features. And then these fine-grained features are being identified only by the experts. Okay. But each time you may not be able to get an expert to identify such kind of images. Now the features are getting more complex. So the model which we have built with a similar or simpler features may not work here. Okay. As we are moving towards the complex features, we are also we need a model which is more complex in nature. That's why we are moving from the ML model to the deep learning model. Okay. So how this recent vision models are working? Okay, when you give an input image to a humans, we see image of this kind. But when you give this similar image to a kind of a machine learning or the computer system, you just, as you might be aware, that machine will process the bits and bytes. You will just get these kind of numbers. Okay. Now, as I said that we are moving from a machine learning model to a deep learning model, here you can say that there is a kind of neural networks which work, and then it processes some kind of information which is very complicated to understand, and then gives you an outcome, whether the image is of parrot, swan, crow, or duck, right? I'm not going to into much details of it because it might not be of interest to many of you. So just assume that this is a very complicated system wherein all neurons are connected, and then they are forming a kind of a network which is recently a field of there is a boom of AI, the deep nets in AI. Okay, this is an example of a fully connected layers or fully connected network. Now, rather than using that fully connected network, we are going to have more, rather than processing the complete image as a whole, can we just focus on the different areas or different parts of an image? Then we go to the convolutional neural networks, okay? Wherein we are having a number of filters, and these filters try to identify particular characteristics of an input image. And then we use a fully connected network. Rather than processing the whole input image, input pixels, we are focusing on the different areas, and then we are processing it in a simple terms. But what happens here is, like, the deep neural networks require millions of samples for training. At the same time, it does involve highly complex nonlinear mapping between input and output. Okay, and we are not aware about what exactly is happening, and in most cases, this DNN is treated as a black box. Now, in order to bridge the gap between human and machine intelligence that I mentioned, and more specifically here, we are looking for the um, problem of recognition. At the same time, how intelligence, or how to bridge the gap between machine and human intelligence, we should be aware about what exactly is happening inside the system. But here we are not aware, or there is not much recently progress in this aspect. Okay, now people are coming with some sort of methods, but it's not in the phase that compared to the humans. So now this is a part of an AI model. So how humans are intelligence? Definitely, this is a question which to be asked. And now, are these AI system are intelligent? As I mentioned, if you give this sort of images to the AI model, definitely it will classify it as a category of a bird, which is the last picture. But we can clearly see that there is one man who is hiding himself in a tent, which is looking like a bird. Okay. So these AI systems are not that intelligent as compared to humans. So that's why we need to understand how AI model works. At the same time, how humans take a decision in favor of a particular class. As I mentioned, and as humans are intelligent because of they are equipped with they are born with a very intelligent organ in their body, which is nothing but a human brain. Okay, so I will not go into much details of it, but I will be happy to take questions offline. So here, just for the sake of understanding this lecture, you just need to understand that uh, the signal from your eye passes to the different areas in the brain, and then the recognition happens. Okay, when you look at different objects, then uh, then you can see that the recognition is happening at the occipital or inferior temporal cortex, IT cortex, we generally say it. Okay, so and simply we can just say that the information is processed to the primary visual cortex, where is V1, and this information flows to the inferior temporal cortex, and then the recognition happens, right? So the simpler structure are been extracted or learned, and then we go for the maximal or the more complex structure. This is how the human recognition system works. Now, as I mentioned, that we need to understand how this decision is being taken by humans. So we need to understand, we need to investigate the brain, and what are different brain investigation techniques are. So there is EEG, MEG, MRI, and eye tracking. All these techniques help you to understand some amount, some things related to the brain, not the complete brain because it's still a mystery. But still, we are trying to use these technologies to understand how human brain works and how it takes a decision, right? Now let's take an example. If I show this image, so can say some of you can say that what exactly you are able to see in this image. I guess I'm not sure whether these participants are uh, so okay, whether participants are allowed to, yep, uh, okay, faces, correct, and again more. Okay, that's correct. So you can see faces, we can also see objects and sorry, not objects. There is a trees and rocks and everything. Before moving further, I just got one question: which deep learning algorithm is most suitable for medical imaging? So yeah, I can come to this point once with at later part of this lecture, maybe, so that you will get an answer to this question. So in this image, as you can see, there are rocks, there are trees, there are different types of, as in two type of horse, man. Okay, so what exactly you are doing here? You are focusing on different areas in that image, and then your brain is processing that information, and then you are coming up with some sort of a decision, right? So right, so these focus points are nothing but called as a fixation, and this fast movement between the two fixations is nothing but saccade. Okay, now as I mentioned that you are not processing the whole image at once, but you are focusing on different regions, and that's why eye tracking seems to be an information or informative technology that can be useful to understand some aspect of recognition, as we are pointing our eyes to the relevant locations, right? And so that's why we are in today's talk I will be more focused uh, with the eye tracking technology, right? So as I mentioned that humans do not process or the whole scene at once, but it is actually focusing on different parts and then acquiring information where it is needed, and then taking a decision. Okay, so now in order to capture this eye movement, we have a device which we call as an eye tracker, and it gives you where exactly the person is looking on the image, right? And there are different types of eye trackers, like eye attached tracking, optical tracking, electric potential measurements, that is, you might be aware. And these are some of the eye trackers that I used during my doctoral thesis. Okay, that too, now I'm using here at MIT, I will be more using the eye tracking goggles, but In IIT Delhi, in my doctoral thesis, I use this screen-based eye tracker where the bottom portion consists of some sensors which are helping you to estimate a gaze position. Okay. And mostly this slide is generally I keep it because it's like the eye tracker cost around 25 lakhs, and if it works on the principle of optical tracking, wherein the infrared light is incident on your eye and you get the Perkin's reflection, first, second, third, and fourth. Out of this, first reflection is being used for the design of an eye tracker. And what exactly is being done, what is algorithm that is used in eye tracker is they just try to map this vector from the center of your pupil to the corneal reflection to get an estimate. So if anybody of you is interested and can have more discussion on this on with me, and you can come up with your own tracker. So for the time being, you just consider that eye tracker gives you a three coordinates as in XY coordinates and the timestamp where you at what time point you are looking at the screen. Okay. Let's take example of a case study. That up till now I just mentioned you about the basics of AI and some related stuff, and now we'll just look at how human learning or how machine learning can be taken together, and just to narrow down the gap between machine and human learning, or let's say intelligence. For that, I had taken the example of character recognition, and which is also a part of my doctoral thesis. So in order to understand that, let's have a quick look as in what exactly the character recognition is. So many of you might be aware that OCR, that is optical character recognition model, wherein we try to scan the documents and try to give it in a editable format, right? So if we look carefully, there are different categories of characters, right? Printed characters. So printed characters, we were having simpler algorithms. Then we move to the more complicated, as in handwritten characters, and now it's artistic or noisy characters, right? So now, as we are moving from simpler to the more complex character sets, so we are actually moving towards the handcrafted features by machine learning and using a machine learning model to the feature extraction to deep architectures. Because the complexity has increased, the complexity of model is also increasing, right? But the question is, how does accuracy improve, and how does this model actually works? So in order to understand this, we need to understand how the system actually works, right? Because humans are very well in identifying the characters which are irrespective of their shapes or irrespective of character structure, right? So now let's try to have a look how human recognizes a character. Okay, for that we need to have understanding about a human vision system, not exactly in more details of it, but on a broader level. So babies born with blur vision start to develop clear vision in few months. Okay, then they are interact with the environment, and then they develop a face, sorry, not face, the shape and object perception. Then they go to the school where they are taught a different sort of characters by the teacher. Later on, they came across to different characters through handwrittens or through hoardings. They are having exposed to the different kind of characters. So all this journey depicts that the humans have vast visual experience. At the same time, characters are overlearned patterns. Okay. Now, when we see that, so for machine learning or deep learning model, we need samples, millions of samples for training deep architecture, whereas in humans, training is happening through visual experience. So the question is, what do the deep architecture learn, and how do humans learn? Now, this, if we are able to address this question, we can bridge the gap between human and machine learning. But at the same time, these questions are very high level, because having an understanding about the visual experience is a bit difficult. So that's why what we do is we narrow down the question, and can we just propose an intelligent model by understanding the strategies used by humans and deep models for successful recognition? This seems to be a question which can be addressed. And that's why we are going with this question and then try to understand the strategies that are being used by humans and deep nets. Now, So as I mentioned that we are moving from handwritten to the sorry printed to the more complex characters. So we came across a character set which is handwritten characters. So as you see here, these are some of the samples of handwritten characters. You can see if we divide a character into different zones, so we can see the maximum variation is in the body of that character. So what we do is we just created a kind of a distortion in each character, and we showed these characters the human subject which is sitting in front of a computer. Yeah, one thing I forgot to mention, that all the experiments have been approved by IRB. So during my thesis that I have been performed, and you just need an ethical approval when you perform any kind of study with human subjects. Okay, just to give you more information about what is IRB and something like that. So when this person is looking at this character, he's trying to identify it and then say or read aloud that character. Okay. Likewise, we got some response in that what is this maximum distortion level wherein the humans are able to identify the character. Apart from that, we also tried to look how this fixation pattern change, how their eye movement change when the distortion level is changing from highly distorted to the more low distortion level. Okay, so we observe that if we categorize the letters in terms of their graphical similarity, we just find out that all the characters which are having similar graphical structure as clubbed together, and then we are try to understand uh, how their gaze behavior is. By the way, this paper has been published in the conference, and you can have a look at this at the top of this slide. You can see the name of that paper. But this gives us a qualitative measure of how character has been identified. Okay, and these are the kind of a character set which has been created, but it's not possible always to have a all characters variation to be created by our own. We need to think of the characters which are already there, right? Because what happens to these character sets, now all these are the character okay, but the variations are very wide. So what is the strategy that human might use to identify these characters, or how that image of a character has been processed, right? So we shifted our focus to this character set, but as there wasn't any characters data set which is available like of artistic characters, we created our own data set by segmenting out each character and then pre-processing it just like an MNIST data set is there. And likewise, we get our data set, which consists of these many characters, these many classes of that character. Now, designing an eye tracking experiment. So in human subjects or in human studies, designing an experiment is one of the crucial tasks. One has to pay a lot of attention to it, because if the experiment is very well designed, then your work is already done, half done, you can say. So in most of the eye tracking studies, what we observe is they will show this stimulus and then a center fixation cross, and then again next stimulus and then center fixation. But what happens here is if we are showing the same image, so there is always a chance that when you are focusing on this cross, if the second stimulus S2 appears, your fixation on the center will be there when this image also appears. So it will be kind of a noisy. So what we did is we just change a bit the location of this fixation cross outside the stimulus image area. That's how we are able to somehow uh, minimize the noise, right? So now here you can see the fixation cross at this corner of this image, and then the stimulus is appearing. Okay, and this will not interfere with the actual gaze track, which we are more interested in when the actual stimulus is appearing, right? Now, if I say show this image to you, can you just identify this? What kind of image is this? You can just have use the chat box. I can see the chat box here. What kind of image? Okay. Yep. So it may look like a P, but I made this instruction that is for the participants that we are more for this task we are concentrating on the Hindi characters. or let's say Devanagari characters. Anyone else? Any guess? Yeah. Yeah. So yeah, I got the answer that Dr. Padna has given is like it looks like a character girl. Okay. So what exactly is happening here? So the P answer is also maybe correct, because if I am not making a statement that this character doesn't belong to a characteristics of Devanagari characters, but as I mentioned, it does belong to the Devanagari characters. So here you can see what the circles are. The circles are nothing but your eye tracking patterns. That is eye gazes. Rather than eye gaze, more specifically, it's a fixation, eye fixation. So there is a difference between eye gaze and eye fixation, because in eye fixation, what we are doing is we are collecting the eye gazes, and from that we are just extracting eye fixations. So eye fixation is about looking at a particular area for certain duration of time. It called as a eye fixation. So here, as you see, the more is the size of a circle, more is the time that has been spent on a particular character image. Okay, so here also you can see that this person has spent more time on this area as compared to this person. Okay, now that's why when you are focusing on different character area, which is not actually the contributing to the character identity, you may not you may or may not be able to identify the character correctly. In most cases, you won't be able to find it correctly. Those who identify it as a girl has clearly said that this is the area where one should focus rather than focusing on different area, right? So it means that the eye tracker is actually giving you some sort of explanation. Now here is again one character. So there are two choices. Either it might be the or it might be raw, isn't it? So the question is, how come the same character but you are getting a different responses? So it's fairly simple, as it's like image of a 6 and 9. The way you look at the character, the way you perceive it. So in order to say that this is the character, what you are doing is you are focusing on this area as well as this area, and then considering that both of these areas are important. The one who is saying this as a R are more focused on this upper portion, and that's why it has been identified as R. Okay. Now, both the responses, if I wouldn't have this character segmentation, or the as this character set has been done by ourselves, we were aware about the ground truth annotation, because these characters are segmented out from the word. Okay, so that's why I say that this is R and this is a correct response. Okay, so as I mentioned, till now we just understood that. So the eye tracking patterns is actually giving you some sort of explanation, right? So we are able to get an explanation by performing an eye tracking experiment. Okay. Now coming back to the second part, which is nothing but what about the AI models, right? Because we got an explanation from humans, that is the recognition involves an information processing through selective focus on image regions, right? And through eye tracking, we are able to get some sort of explanation. But what about deep nets? Because we are using a deep learning model and we are passing these images to this model and then trying to focus. We want to know what exactly deep network is doing, right? So here comes the era of explainable AI, because earlier, as I mentioned in the earlier slide, that we just give a data to a black box and it gives you a result. But now people are understanding the need of explaining that black box. That's why we are coming up with a model with techniques called as explainable AI methods. There are various methods which can be applied, and you can have a look at these, like DConNet, LRP plot, class activation mapping. But among all this, what we need is we want to compare the explanation given by humans at the same time explanation given by machines. That's why we are more focused on the method called as class activation mapping, which the underlying principle is that as similar to that of humans, we can say that these models are also focusing on different areas of the image and then taking a decision. Can we just highlight those areas which are important for the model? And this is possible with a method called as class activation mapping. So I will not go into the much technicalities of this, but there was a method called as GradCam, which gives you the focus point in a particular image. But what we observe is there are some images where the GradCam is not giving you a better solution. So because of the interest of the time, I will skip the mathematics behind it. Then we propose a modified way of GradCam, and we observe that when we apply our model or our technique, you can see that the character set where the earlier GradCam was failing, here we are getting a fairly good result. Also, we also showed that on the basis of probabilistic modeling, we showed that the probability of getting positive activation for our method is greater than the earlier method. So you can also have this paper is there on my archive profile, but as it is under review in one of the journals. Now, if we want to compare this fixation map, we also call this as the attention map, as it is giving a proxy of an human attention. So what we can see that, so we got a both explanation now. We have explanation from human, at the same time we have explanation from deep nets. What we observe is when the focus is on the, when the character is correctly classified, the focus seems to be on the similar area. Whereas when the deep model is not focusing on the similar area as that of humans, the character is getting typically misclassified. Okay, now we got a result. Now it's like we understood how deep model is working, how not exactly how deep model is working, but some sort of where exactly the focus is on while taking a decision in favor of a particular class. Okay, now in order to match this, or we want to make our models near to the human recognition abilities. Okay, so we need to somehow do some sort of modification in the model or propose a different model. So we propose a model called as visual explanation guided attention model, wherein we are using two losses. There is a cross entropy and one is MSE loss, and then training this model. So the main aim is just to make a model focus on the similar area as that of humans. That's the whole idea behind this model. Okay, though there are many complications which are involved, and it is been given in the paper. You can have just look through my Google Scholar website, Google Scholar. And here what the result shows is, sorry for this, I think my Mac is not able to identify these characters, maybe. So it's the R, the and M. So these are the first column shows the input images. Second is the human fixation. Third is the model without eye fixation maps. So here you can clearly see that when you show a R as an input image, the model is not able to identify it as a R because its focus is scattered. And here also the same case. When you try to make a model focus on the similar areas of humans, you can clearly see the character which is incorrectly classified is getting correctly classified. Okay. Likewise, we got this for similar for this Latin characters as well, and we have seen there is an improvement in the accuracy. Okay. Now the incorrectly classified samples are getting correctly classified, but what about the correctly classified samples? That is again one question. So what we observe is the correctly classified sample remains correctly classified with increase in the confidence. Confidence is nothing but a probability corresponding to true class. It is actually improving, right? So these digits, that is 0.360, shows the probability corresponding to true class. Now, somehow we are able to bridge or narrow down the gap, right? Through explanations, that is visual explanations. But this model has a limitation that we require visualization map for training through a GradCam, and also it requires architectural changes. So what we do is and it was not possible to apply for the model which consists of dense layers. So that's why we moved to a different model on the concept of deep supervision. This is one of the paper which has been published in one of the premier conference in document analysis and recognition. Here we use the concept of a deep supervision. So as in the deep supervision is like we are trying to train the intermediate layers of the deep nets. Okay. So here we are, the idea is the same, that model should focus on the area which is, or image regions which are fixated by humans. Okay. So based on this, we are using again MSE laws and cross entropy laws and trying to match it, like, and this concept has given us a better results. So here you can see input image, that is a fixation map, which is a eye fixation map, and this is a baseline model, that is model without eye fixation, and deeply supervised model. So you can see that when you are making a model look at the similar area that the humans, we are getting a fairly good results, right? And it is applicable to all the models. Now, revisiting our hypothesis. The hypothesis was on both the model, which is visual explanation guided, that is explainable AI model, and deeply supervised model, based on the principle that model should focus on the similar regions that are fixated by humans. But there is again one problem. So here we will see it. Can you just identify the characters based on this image? I'll just write in the chat box if you can say what kind of character it is. Yeah. Now, not really. So, but somehow you are able to say some kind of a characters. So this is a character curve. I know it's a bit complicated to identify, or it's not a normal, as in normally written. It's a bit tilted one. Now, as I mentioned that in our earlier hypothesis, we are making a model focus on the similar region and that of humans. If we just focus on that area, the character may not be correctly classified in some cases, because we need both foveal and parafoveal regions for correct identification. An eye tracker is unable to capture the parafoveal regions. That's why in most of the cases, the characters was not getting correctly classified. Okay, though these cases are very rare, but still we need to look at all aspects. Now, when you say that this character is curve, we are not exactly, though you are focusing on this area, at the same time you are taking into an account these curves, which an eye tracker is unable to capture. Okay, so that's why we need both area. In some of the cases, you can also see here this baseline model, that is model without an eye fixation map, is focusing on this area, and this character is correctly classified. But when we make it focus on this area, the resultant focus is here, and the character it's wrongly classified. So it means that we need to take care of both foveal and parafoveal regions, and that's why we need to have further modification in our model, and which we propose is a collaborative human machine attention model. Now, there is a concept, if you look at some literature on the human brain, you can see that there is a dorsal and a ventral pathways. Okay, the dorsal stream says that where to focus, and the ventral pathway is what to focus. If we extend this idea to the deep net model, the spatial extent of a channels may be considered as a where to focus, and each channel is a feature detector which will say that what to focus. Okay, we are more interested in where to focus on an input image. Okay, so that's why, and a pooling operation is like supposed to highlight informative regions. So using this idea, what we did is we proposed a model which we call as collaborative human attention model, which uses this module. Now here we will get a network attention map. At the same time, we'll get visual attention map, which is nothing but a fixation map. And when we combine these two, will get a refinement in a feature maps, which gives you a better result. Okay, this paper has been published in conference ICPR, which is also a premier conference in pattern recognition. You can just have a look at this. And if we look at this as in the results of this model, so we can clearly say that it outperforms all the models that we mentioned earlier. And through visualization also, we can see that this model is doing fairly well compared to the DeepNet's earlier model that we proposed. Okay. Now, as we mentioned, most of the DeepNet models work on the principle of IID, that is, the testing data is also coming from the same distribution as that of a training data. But now we want to apply, as in to use whether this model works on other data set which is not from the same distribution. So we tested our model against the handwritten character data set and the transformer character data set. And we also created some of the distorted character data set. And what we observe is both our model do fairly well in generalization. That is, it gives you a better results even when the data is from the different distribution. Okay, so that's why we say that the fixation maps are helping network generalize well. But still, though we are able to somehow reach to some level of expertise or some level of what to say, narrow down this gap, but still human recognition performance in all these data sets is 100%. We are still not able to reach to that level, but further research or further direction should be like one should focus on how humans do take characters, as in how do humans recognize characters, or let's say anything which is human are capable of, and how machines are doing it, and then you try to understand both things. If we proceed in this direction, one can easily say that we are trying to build up an AI model which is more robust, or which is near to that of near to that of the human intelligence. So this is one of the case study, but what are the other projects that I am a part of? So I will just try to highlight those. I think we have time. Yeah, we have time. Okay. So from eye tracking, let's focus on the eye tracker first. So sorry, this video is not playing, but we can also say that we can also infer the language expertise from eye movement, right? So sorry for this because it's not playing. So from eye movement, one can easily say that whether the person is expert in a particular language or not. There is also a concept called as visual attention in eye movement data. So eye tracking has been used in the reading studies since long ago, and it's like, but there are not much study that are reported in terms of the reading behaviors using different font types. So we generally come across different font types and font sizes. So what we did is we just tried to look at the effect of font type on reading comprehension and eye movement behavior. So what we did is we just selected some of this proper character fonts and just made some documents and then showed these documents to the different readers and just try to look at their eye movement behavior. So the video which is not playing, it's actually will be showing you the gaze patterns, how these gaze plots are. So here you can see that they there are maximum number of eye fixations for a longer duration. Here these are fairly less, and here it's very less. Okay, the size of a circle is nothing, varies as a function of a fixation duration, right? It means that this document is a bit complicated to understand compared to this one in terms of a font type. Okay, we are keeping the complexity level as in the same, just we are modifying the font type. So you can see that there's different character code written in different fonts. So how this is having an effect on your eye movement behavior. So earlier case, it was assumed that if we have more fixation duration, more fixations on a particular document, particular thing, then we can say that there is more processing in the brain, At the same time, more reader engagement with the document. As the readers are more engaged in reading, they are able to extract maximum information, and then the reading comprehension is also improving. Okay, so this paper is also published. You can have a look at this. And there is again one thing that I worked with a collaboration with one of my colleagues. So there is a concept called as a memorability. So in image compression, we also tried to use an eye tracking as a ground truth data annotation. So there is a concept called some of the images are memorable and some of the images are not that memorable. So here is a data set which is there. Sorry, I forgot the name of the data set, but you can have a look at our paper, which is published in one of the journals. So here you can see that these images are memorable and these are average and these are forgettable. So what we did is we just showed these images to human subjects and then try to see that where is the human focus, and what we also propose a method of memorability, and then we compare both. So here you can see this image is memorable because maximum people are focusing on here, and then this area might be the of interest to us. Okay, so eye gaze can be used as a ground truth data generation, and we can compare our method against that ground truth. So there are other projects which I worked with, as in face and object categorization using eye tracking, visual search, and reading experiment that I talked about. Now, among all these techniques, there is we are coming to the last part of my talk, which is my current project, which is I'm working on. Though I worked with this project since a lot of, as in from during my PhD as well, but still I just thought of introducing some bits of this project, which is the last portion of our presentation. So this is a project Prakash. So this is one of the interesting projects that I came across, and I'm really thankful to my mentor for giving me an opportunity to work in this project. So so in the outline slide, I mentioned that there is like need for working for humanity, and this project is a humanitarian project, so which actually worked which is in which we work with a blind child in India. So the figures denote that 1 in every 100 Indian is blind, and the incidence of blindness is more in the West as in the time. Okay, so these kids are born with a blind vision, and they are not treating they are not treating it, because overall 40% of the childhood blindness in India is either treatable, but because these people or these children are not getting a treatment, they remain blind. And we categorize these children as a congenitally blind, and then we ask in under this project they are treated at Shroff Charity Eye Hospital in Delhi, and then we look at the understand the trajectory. So because the children are blind by birth, there are various consequences of this, like it's because of which the lifespan is getting reduced by 15 years, and employment is less. There is a lot of problems in their life. Now, under this project aims to provide a treatment to the curably blind children. And at the same time, we also try to see the scientific opportunity, because there is theory that if a person is not able to see by birth, and as he starts gaining the visual sight, his brain may or may not be able to learn. That was a question. So in order to target that question, it gives us an opportunity to look for the scientific advancement with this clinically identified a different category of a subject. Now, using these two, that is humanitarian need, at the same time the scientific quest, this project, that is a project Prakash, has been introduced, which is been funded by MIT and some of the donors from India and outside the world. So under this project, we have different teams like outreach, and treatment team, and research. So I'm a part of Project Prakash research team since 2016, and I'm still working here. And now it's my main work of finding out the research, wherein I will be more focused on understanding the cognitive abilities of those using fMRI technique. So this under the outreach team, what happens is, which is outreach team go to the different villages and they have their camps, and they identify the curable blind children, and they are being asked to come to the charity Shroff Charity Eye Hospital in Delhi, which is a headquarter for Project Prakash, and then they are being treated there. The treatment is like there are various experts or expert doctors which are there. They operate on these kids, and then they are able to see the world. Now, what our job is to understand how vision develops after the sight onset. But again, how vision develops is a very high question. The first question that needs to be at whether vision develop after the sight onset. Sight onset is nothing but once we treat their these kids are having the congenital cataract. When we remove it, they are able to see the world, and that's why we are naming it as a sight onset. Now there are different projects which has already been published in one of the high impact factor journals like Proceedings of National American Society, Psychological Sciences, wherein we are studying the different aspect, right from the motion prediction till the identification of an object or faces, and looking at different abilities of this. So you can always have this, you can find this publication under heading of Project Prakash. And we observe that through this project, there has been tremendous improvement in the quality of life. And as a part of a Project Prakash team member, I am looking at EEG studies. I was looking at as in when I was in IIT Delhi. So I was just trying to find out the neural correlates for face and object recognition. At the same time, also involved with biological motion, how motion is being pursued by this newly sighted kid and I was using an eye tracking technology for it. At the same time, there is a task called as referential communication task, which is wherein when these kids are able to see and how they interact with the different objects, how they name those objects and how they refer those objects, because they are blind and now they are able to see. So how this, whether they are using size, object size or object structure as an explanation, or as a kind of cue for the communicating about describing the object. So this is how, as in my, I am really blessed to have this wide variety of research areas to be associated with, right from the NLP to the basic sciences and AI, of course. So this it has a very broader impact this project is having, because even though this project is more focused on India, but it has an impact till the USA, because if you look at, there are some papers that I'm also happy to be a part of autism team as well at MIT. I'm also associated with it. So these theories that are proposed in the Project Prakash, the experiment, has implication for diagnosis of therapies for autism. So there is again a separate paper which is autism as a disorder of prediction. This is a wonderful paper. You can also have a look at it. So wherein we are looking at how this autism is a disorder of prediction, how this predictive abilities can be improved for the autistic kids. Now, there are different aspects wherein we actually work on, like from blindness, insights regarding brain plasticity and learning, which is brain plasticity will be my major area of research for my postdoctoral studies. And also AI system, these models can also help you build up a better AI system. So in a way that this project is giving you opportunities in different areas to work with. Now, what is the impact of this project is around 43,000 children are screened and 501 are provided surgeries, though these figures are a bit old, and some of them are also provided non-surgical treatments. So this project has been really doing wonderfully well, and it is giving us an opportunity to explore more aspect of brain. So it has been published in as a cover page of the Science magazine. in 2016. At the same time, there has been various articles which are published in Nature Neuroscience, Nature paper, which is highly cited or high impact factor journals. It's also the Times, New York Times has also taken this idea, or as in has been published in the New York Times as well. It's there on the Time magazine as well. And the best thing that we observe is like self-reliance. Now this kid was blind earlier, but when he was treated in this Project Prakash, and now he is able to run the bicycle. So instead of looking for all those scientific discoveries and all, this image gives you a kind of uh, a great satisfaction that we are doing something for humanity, and our efforts are being directly visible as the quality of life is getting improved for this kid, right? We do also have some sort of activity after this, all sort of research activity that we do after the surgeries of these kids. We call this as the Andruli art, wherein as they are able to see and they are interacting with the colors for the first time, they are just throwing the colors the way they want. And their pictures are been showcased in one of the galleries in Princeton University. Yeah, and I was also been featured in one of the magazine in Germany, that is a Geo magazine, and also when I was doing EEG studies, this has been captured, and also a documentary has also been as in shooted by one of the, I think it is Netflix, so it might be released soon, which is a documentary on this project. So yeah, that's all from my end, and I'm ready to take the questions for today. And I believe, yeah, I was given a time of 1 hour, exactly 1 hour I finished. So thank you so much for listening so patiently, and I will be definitely happy to take the question. So going back to the chat box, which algorithm is suitable for medical imaging. So to answer this question, so as I mentioned that in most of this deep learning models, we are using it as a black box in most of the cases. So when you use, or we are not aware about what is happening inside this black box, so that's that's why it becomes difficult for us to which particular medical imaging uh, data, or which particular medical imaging can be applied or can be used for it. But what I suggest is you just have a quick look at the literature, what kind of algorithms that are being used. So I had seen people being using different sort of models. So basically those models which are having a uh, better recognition reported, accuracy reported, you can just go for it. But I will suggest, rather than using your own network, I will definitely recommend the models which are already there, like AlexNet, ResNet. Based on your case, you just try to use those models and try to do something out of it. But at the same time, if you are able to use some sort of techniques using explainable AI, it will be an added edge for your research. So I will definitely suggest to go for an explainable AI, so that this model will not be limited to the research paper, but it can be applied to the medical field as well. Okay. So
next question is whether both data sets are available as open source.
Which data sets?
I think it is related to eye tracking or memorable images.
Yeah, the memorable images dataset is already there. If you look at this paper, we had already taken the dataset. And related to the eye tracking, it's like my paper has to be published by one of the journal first, and then I will make it public. So it's not yet public, but yeah, definitely I will make it public.
Next question. How can we get IRB approval in India?
Yeah, that's a good question. So one of the most important thing is, whenever you go for any sort of studies with human subjects, you are supposed to get an IRB approval. So now IRB is like there are institutes wherein this kind of experiments are being done. They have their own committee, and that committee involves right from the common person to advocate, doctor, and there are a lot of people who actually look for your proposal, and then they decide whether it is harmful for any person or not. So each institute is having his or IRB committee, and based on which you are submitting an application for that. So I believe that I am not sure whether your institute is there or not, but if not, you can always collaborate with the institute. Like if the data is coming from the medical side, then AIMS or any hospital will help you out to have a good IRB setup, and then you can look for it. But I don't think that now recently there has been as in there are people who are working in engineering colleges also with the human subjects. So you can also look for it if it's there in your institute, or you can also propose for establishing an IRB committee in your college. I hope I answered this question.
Next question, which software used for deep learning?
Yeah, that's a good question. So what I will say is, if you are a beginner for a deep learning model, so I didn't include the slide how to get started. So in order to venture into the deep learning side, or so what you should have knowledge about probability and statistics. These are the two subjects you should be aware of. And and then if you go for the implementation point of view, you should be, though MATLAB is also been good at doing this deep learning model stuff, but I never used MATLAB, but I was using the Python based frameworks. So I used Keras, TensorFlow, and PyTorch. So no need of using all this stuff, but as my research demanded me to do so, though I used all of this, you can get started with TensorFlow and Keras and get versed in Python first. So then it will be very useful for you. And for practice, you can also use the Google Colab or some other libraries, online platforms which are available.
One more question. Can you share your thought on a support vector machine algorithm? Support vector machine algorithm.
Yeah. So SVMs are used for as in the binary classification or the classification purpose. You can use it. So I am not a good, I don't believe I am a good person to be addressing those, because I haven't worked with SVM specifically. But yeah, you may find out different articles there on the SVM. So it's there. And so I don't think I should speak more on it, because I haven't used it much, though I had worked with it at the initial stage of my coursework at IIT Delhi. But yeah, mostly I don't have much idea about it. But yeah, if you go through the different articles, you will definitely get it.
Any questions from participant? Any more questions? Should I go for Python or MATLAB for segmentation?
Again, it depends on your kind of the research problem you are targeting. As in, suggesting a software will not be may not be a good answer to it. But what I suggest is just look for, if you are a beginner and you want to explore this area, go for the first thing that you are more comfortable with. If you are more comfortable with MATLAB, then go for it. If you are more comfortable with Python, then I will suggest for Python. So for Python, you may get different blocks which are there because it's freely available, and it will be helpful more, because if you look for any query and you directly put it on the Google, then it will give you some sort of idea about how to go about it if you are getting stuck at some point. But for MATLAB, the support might not be there because I haven't used MATLAB that much. But if your purpose is served, then both of them are equally well. It's not about Python and MATLAB. It's about the clarity that you have with your algorithm and ease that you will have while using these softwares. So that's the thing that I feel.
Yes. Thank you, Chetan, for your valuable inputs and focusing on one of the thrust area. Also, we are extremely grateful that in spite of the time difference, you have delivered this session according to our schedule. I request you to accept a token of gratitude on behalf of organizing team and Yashwantrao Chauhan College of Engineering,
Oh, thank
Nagpur,
you so much.
for sparing your valuable time and guiding us. Thank
Yes,
you.
thank you. Thank you so much, and thank you so
Yes.
much for having me
Yes,
here.
yes, all the participants, please turn on your camera for photograph. Done. Thank you.
Okay, thank you so much for having me here. And if you have any questions, I will definitely ready to answer you. You can just write down my email address as in cralekar@mit.edu. You will I will definitely get back to you if you have any questions. And thank you so much for giving me an opportunity to work, to deliver a talk with all of you and to interact with you. Thank you so much.
Participant, tomorrow we will have a session at 10 o'clock, morning 10 o'clock. So same Zoom link meeting will be there. Thank you. Feedback link is posted in the chat box.